Have you ever been stuck in traffic and watched the car in front of you creep along? It seems like it's barely moving at all. Then suddenly you realize, wait a second, we're actually moving too. We're not still. We're just moving at the same speed as the car in front of us. When you think about it like that, it seems kind of strange, doesn't it? How can you tell if you're moving or if you're standing still? If you want to know why does your car seem still when it's moving, keep watching this video. In this video, you will learn why it feels like your car is still when it's moving. Now let's get started. When you're sitting in a car that's moving, it can be hard to tell if you're moving or if you're standing still. That's because it's relative. You're moving relative to the ground, but also relative to the car. In other words, your motion is relative to the frame of reference that you're in. To better understand this concept, let's start with a simple example. Imagine that you're standing on a train platform and you see a person walking towards you. As the person gets closer, you might think they're walking slowly, but as they approach you, they seem to be walking faster. And once they pass you, they appear to slow down again. What's really happening here is that the person's speed is constant, but your perception of their speed changes based on whether they're coming towards you, passing you, or moving away from you. This is an example of relative motion. Now let us imagine that you are the one walking and the person on the platform is standing still. If you were to describe how fast you're walking, you would probably say that you're walking at 3 miles per hour or 5 kilometers per hour. But that's only true if the person on the platform is standing still. If you were to describe how fast you're walking relative to the person on the platform, you might say that you're walking very fast. Let's go back to the example of being stuck in traffic. When you're sitting in a car that's moving at the same speed as the cars are on you, it can be hard to tell if you're moving or if you're standing still. That's because you're in a frame of reference that's moving at the same speed as the ground. So, you don't perceive any change in your motion. However, if you were to look at the car from an outside frame of reference, such as from a plane in the sky, you would see that the car is moving even though it seems still to you. There are two frames of reference here, the car and the plane. From the frame of reference of the car seems still, but from the frame of reference of the plane, the car is moving. This can be confusing, but it's important to remember that motion is always relative. There is no absolute motion, only relative motion. Now let's take this one step further. Let us say you're in a car that's moving at a constant speed on a straight road. You're not accelerating, so there's no force acting on you. According to Newton's first law of motion, an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an imbalanced force. Since there are no forces acting on you, you should remain at rest relative to the car. But what if you were to look out the window? You would see that the trees and buildings are whizzing by. This is because you're in a frame of reference that's moving, even though it doesn't feel like it. In order to understand this, we need to define a few terms. An inertial frame of reference is a frame of reference that is not accelerating. A non-inertial frame of reference is a frame of reference that is accelerating. When you're in an inertial frame of reference, you can use Newton's laws of motion to predict how objects will move. However, if you're in a non-inertial frame of reference, Newton's laws of motion do not apply. Instead, you need to use Einstein's theory of special relativity. So to summarize, when you're in a car that's moving at a constant speed on a straight road, you're in an inertial frame of reference. The car is moving relative to the ground, but you're not moving relative to the car. So it feels like you're standing still. However, if you look out the window, the objects outside the car are moving relative to you. This is because you're in a different frame of reference. That's why your car seems still when it's moving. It's all about relative motion. Thanks for watching. See you next time.